To find the volume, I selected 3 vector and put them in component form. These are my 3 vector. They started at the origin 0, 0, and these are the factor and component form. The volume is going to be the value of the determinant, -1, 2, 2, 2, 0, 1, 1, 2, -1. Here, all what I want you to do, multiply the first row by +1, -1, +1. So when you do the expansion, if you look at the first row, first column, +1 times -1, it remains -1. -1 times a minor, and the minor will be 0, 1, 2, -1. -1 times 2 will be the second minor. The second minor is going to be multiplied by -2, and the component will be 2, 1, 1, -1. The last one is the last column, was the first row, and that will be +2. 2 times 1 is 2. If you look at the minor, it will be 2, 1, 0, 2. Now let's go ahead and finish up the multiplication. And to finish up this multiplication will be -1. Multiply this way is 0 minus 2. Here we'll have -2 times. Multiply this way, you'll get -2. Multiply that way is -1. Here we're going to multiply one direction, will be 4. The other direction will be simply 0. So that will be +2, -3 times -2 is +6, +8, and this will be 16. Good thing it's positive, because if it wasn't positive, you can make it negative. Next, we're going to look at number 8. And for number 8, here's what I want you to do. To write an equation of a line in parametric form, given 2 points on the line, and the point are 0, -10, 3, and the other point is 5, 10, 0. We need a point, we have 2, we need a vector parallel to the line. If you take those 2 points that are on the line, excuse me, and put them in component form, you create a vector parallel to the line. So to put that vector in component form, that vector is going to be terminal minus initial for all 3 components, and the vector will be 5, 20, -3. We're going to call this one ABC. We're going to pick one of the points and call it X1, Y1, Z1. Okay, so now to write it in parametric form, X is going to give you 5 plus 5t, and Y is equal to 10 plus 20t. Z is equal to 0 minus 3t. That's the parametric form of the equation. If you choose to put it in symmetrical form, it's going to be x over 5 is equal to y plus 10 over 20, which is equal to z minus 3 over -3. Here I selected a different point. Part B. Write an equation of a line that goes through the point 1, 2, 3, which we're going to call x1, y1, z1, and it's already parallel to a vector that's given to you, -2, 5 over 2, and 1/3. The only thing I need you to recognize here is this vector is going to be your ABC. However, when we write an equation of a vector, I don't want it to be in fraction form. Can I multiply the whole vector by the common denominator and make it a little bit longer? The common denominator is 6. If I multiply a vector by 6, it's okay. You're not changing anything. You're just making the vector a little bit longer. It's still parallel to the line. So that would be -12. 6 times 5 would be 30 over 2, which is 15. 6 times 1/3 is going to be a 2. So the equation of the line is going to be x is equal 1 minus 12t, y is equal to 2 plus 15t, and z is equal to 3 plus 2t. If you choose to put it in a symmetrical form, x minus 1 over -12 is equal to y minus 2 over 15, which is equal z minus 3 over 2. All right, part C. Part C, we write an equation of a line that goes through the point 3, 2, 1, which we're going to call them x1, y1, z1, and the line happened to be parallel to a second line, and the line is given to you in symmetrical form, x minus 1 over 2 equal y over 1, which is equal to z minus 3 over -3. If you look at the denominator of that line, it's a vector parallel to the line. That vector is going to be called ABC. It's 2, 1, negative 3. Since the lines are parallel, I'm going to use this vector because it's parallel to the other line and write the equation of the line. So x is equal to 3 plus 2t, y is equal to 2 plus 1t, and z is equal to 1 minus 3t. In symmetrical form will be x minus 3 over negative 2, y minus 2 over 1, and z minus 1 over negative 3. Okay, for part D, we have to write an equation of a line that goes through the point negative 4, 5, 2, and it's perpendicular to the plane negative x plus 2y plus z equal to 5. Now, keep in mind, here is the visual of it. You have a line perpendicular to the plane. We want a vector parallel to the line. Another vector that could be parallel to the plane is this vector here, negative 1, 2, 1. This vector, we know it's perpendicular to this plane. However, it's parallel to the line. So we're going to use this vector to write the equation of the line. X equal negative 4 minus t, and y equal 5 plus 2t, and z is equal to 2 plus 1t. To write it in symmetrical form, it's going to be, I don't have the points in front of me anymore. Okay, so it's going to be, maybe hopefully I can fit it in, x plus 4 over negative 1, y minus 5 over 2, and then z minus 2 over 1. Done. Here I have 3 points in the plane. I need to write the equation of the plane. So I took the point A, B, and put them in component form of a vector, and then I took the vector AC and put it in component form. AB turned out to be 5, negative 2, and AC happened to be 3, 5, 2. Do terminal minus initial for each one of those. Now we have to find the vector that's perpendicular to the plane by doing the cross product. So we got the I, the J, the K. 5, negative 2, 3, 5, and 2. Change the sign on the first row, and then here only you have to change it on the J. Do the expansion, take your time. I'm going to give you the answer, and the answer is going to be 0i minus 16j plus 40k. So the vector perpendicular to the plane is 0, negative 16, 40. I'm going to use this vector as ABC, one of those 3 points that came up ahead. I'm going to pick maybe point A, and then write the equation of the plane. And the point A in this case was negative 1, 3, 4. So that was my x1, y1, z1. The equation of the plane is going to be 0 times x plus 1, which doesn't have any point on right in it, y minus 3 plus 40, z minus 4. Okay, to simplify this, we'll give you negative 16y plus 40z, and then here you'll have 48, and here you will have negative 160. To simplify this equation, and just make sure the leading coefficient is not negative, and then you have to reduce the common factor. So I went ahead and divided by negative 8. Dividing by negative 8 here, negative 8 here, and negative 8 on all of these. Okay, dividing by negative 8, this will get you 2. Okay, dividing by 8, this will get you 2y. This 40 divided by 8, negative 5z. And this one, if you add and divide by negative 5, will be plus 14 equal to 0. This is the equation of that plane. Done.